Morning everyone. Myself Agalya, currently working as an assistant professor, Department of Computer Science and Engineering at Sri Muthukumaran Institute of Technology. In upcoming semester, I am going to teach data structure using C++ for first year ECE student. In this video, I will explain the basic concept of data structures using C++. Before we go into the subject, let us first look at the course outcomes given for this course. CO1. Explain the concept and application of data structure in various engineering applications. CO2. Apply various data structure in real time. CO3. Develop suitable and interrupt data in real world application. CO4. Focus checking out the efficient solution in terms of time and memory. CO5. Implementing all this concept practically using C++ programming. Let's move on to the next slide. What is data structure? A data structure is a method of organizing, storing, and managing data efficiently. It enables faster access, modification, and processing of data. Efficient data structures lead to optimized algorithm. For example, organizing your books on a shelf. If everything is in order, you can find what you need fast. If not, it takes a lot of time. It helps us do things like to store a list of items, manage tasks, or keep track of information efficiently. Let's move on to the next slide. How do we use data structure with C++? Data structures are used to solve complex programming problem because C++ is a fast language and it gives us full control over memory. So when we use data structures in C++, our program works faster and better. Classification of data structure. Data structure classified into two types, primitive data structure and non-primitive data structure. The non-primitive data structure further classified into two types, linear and non-linear. Let's explain step by step. Primitive data structure. Primitive data structures are basic data types provided by C++. They are the building blocks for constructing complex data structure. In this image shows examples of the primitive data structure that int, float, double, char, bool. Int represent it used to store integer value and float represent it used to store decimal value and double represent is used to store double precision decimal number and character it stores a single character value. So these are the common data type. Let us move to the next slide. Non-primitive data structure. Non-primitive data structures are complex data structure used to store and organize large amount of data efficiently. They can store multiple value at a time. They help in efficient data processing and manipulation. The non-linear is further divided into two types, trees and graph. Let us discuss later. Linear data structure. Linear data structure store element sequentially one after another. Each element has a unique predecessor and successor. implement using arrays or pointer. For example, if students are sitting in a single row, each student has one student in front and one student behind. Is this similar to how data is stored in a linear data structure? As you can see in the diagram, each element has only one previous element and one next element. So the data follows a straight line order. Let's move on to the next slide. Examples of linear data structure. It consists of four types: array, linked list, stack, queue. Let us explain one by one. Array. An array is a linear data structure. It stores multiple elements of the same data type. Elements are stored in continuous memory location. Each element is accessed using an index. For example, if I want to store marks of 5 students, instead of using 5 different variables, I can store all the marks in a single array. So, array make data storage simple and organized to access the data faster. Now, let us see how an array is represented. As you can see in the picture, each box represents one array element. At the top, we have index value starting from 0. Below each index, actual data values are stored. So we access array element using index value like array of 0, array of 1 and array of 2. This index based access makes the array easy and faster to use. Let's move on to the next slide. Linked list. A linked list is linear data structure made up of node. Each node has two parts. One is data and another one is pointer. The data which stores the value and a pointer which points to the next node in the list. This diagram shows a linked list. The first node has 10 points to 20, then 20 points to 30 and 30 points to 40. The last node points to null, showing the end of the list. It shows how nodes are connected in a sequence using pointer. Let's move on to the next slide. Stack. Stack is a linear data structure, follows first in, first out principle. Insertion and deletion are done at one end only. That end is called the top. This means the last element added to the stack is the first one to be removed. This diagram shows a stack how the top element access first while adding or removing the element. Let's move on to the next slide. Stack principle. It follows first in, last out principle. Last inserted element in the first one to be removed, similar to the stack of plate. Let's move on to the next slide. Stack operation generally have four main types. First is push. This operation add an element to the top of the stack. For example, if we push 10, it becomes the top element. Next, pop. It removes the top element. For example, if the top element is 10, top will remove it. Next, peak or top. It allows us to see the top element of the stack without removing it. Finally, is empty and full. Check whether the stack is empty or not. It returns true if there are no element in the stack. This operations helps in managing element of a stack efficiently. Queue. Queue is a linear data structure that stores element in a sequential order. It means the first element added to the queue is the first one to be removed. There are two main operations in a queue, NQ and DQ. NQ add element to real of the queue and DQ remove element first of the queue. Let us understand a queue with example. Think of a queue like a line of students waiting for this turn. First 10 enters the queue, then 20 and 30 are added at the here end. Now when an element is removed, 10 comes first. Become it ender first. This follows first in first out principle. So the element that comes first, it remove first in a queue. Let's move on to non-linear data structure. Non-linear data structure store element in a hierarchical or interconnected manner, not in a single sequential order. This structure are used when relationship between data items are important. Let's move on to the another side. Examples of non-linear data structure. Tree stores data in a hierarchical structure with parent-child relationship. It stores data in hierarchical manner. Elements are connected using parent-child relationship. Next slide. Terminologies used in tree. The root is topmost node of the tree. A parent is a node that has one or more child node. A child is a node that comes divided from a parent node. Leaf node is a node that has no child node. The level of node shows position in the tree starting from the root. The height of the tree is the maximum number of level in the tree. Let us move to the another slide. Graph. A graph is a non-linear data structure made up of vertices and edges. Vertices represent node, edges represent connection between the node. Graphs are used to represent real-world connection such as social network, roadmap, and computer network. Let's move on to the another slide. Types of graph. Graph can be directed or undirected. In directed graph, edges have a direction. In a undirected graph, edges do not have a direction. In weighted graph, each edge has a value called weight. It represents distance, cost, or time. Example, in a road map, the weight shows distance between the two cities. Unweighted graph, it shows only whether a connection exists or not. Conclusion. Data structures are essential for organizing and managing data efficiently. They provide a way to store, access, and manipulate data effectively. Understanding data structure is fundamental for programming algorithm and real world problem. Thank you.